All right, so for day 3 here, we're going to have 5 additional questions to help you guys get ready for the final. All right, so the first one here. We have a 200-foot high television transmitting tower. So I'm going to draw my tower, which is 200 feet tall, and is supported by a guy wire running from the ground to the top of the tower. So from the ground to the top of the tower. And it says that the wire makes an angle of 63 degrees with the ground. So this angle down here is 63. We know this creates a right triangle. Okay, so the first thing it says is how long is the wire? So that would be solving for the hypotenuse. So this is going to be a SOHCAHTOA question. And we are given from this angle 63 degrees, we're given the opposite side, and we're trying to find the hypotenuse. So I'm going to use sine of 63 degrees equals the opposite side of 200 feet over the hypotenuse of x. I'm going to move that x to the other side with multiplication to write x times the sine of 63 degrees equals 200. Divide both sides by that sine of 63 degrees, and so here is my exact answer. I'll go ahead and go to a calculator to give a rounded answer to the nearest foot. So 200 over the sine of 63 degrees, which is approximately 224 feet. Okay, so same figure, but part B says how far from the base of the tower must the wire be to meet the ground, or to be on the ground. So this right here I'm going to say is y. That is how far from the base of the tower to where the wire meets the ground. All right, so again, I'm using this 200 feet, but that is the opposite side from 63 degrees, but I'm no longer solving for the hypotenuse. I'm solving for the adjacent side from that 63 degrees. So I'll be using tangent of 63 degrees equals opposite 200 feet over adjacent. Same process, move the y over with multiplication. Move the tangent of 63 over with division. And there is our exact answer. And I can get an approximate answer by doing 200 over the tangent of 63 degrees. So 200 over the tangent of 63 degrees. So approximately 102 feet. Okay, so that is it for the first question. Let's go to number 2. All right, so number 2, this is kind of similar to one that we did on an earlier video, but you'll notice that the values given, right, none of the numbers given or any of the unknowns are actually like the bases of these triangles, right? So where those parallel markings are. So we're trying to find EC, which is right here. So we'll call that X. So I'm going to use my understanding of the theorem sheet to write 9 over 3 is equal to 15 over X, right? This is different than the way that I set up the proportion in one of the earlier reviews because they had the numbers were not on the sides like this, right? So because of these parallel lines, it breaks this up into proportional ratios. So I can go ahead and set those equal to each other like I've done. I'm going to reduce 9 over 3 to 3 over 1. All right, I'm going to use cross products. So 3 times x is equal to 15 times 1, which is just 15. So x is 5. It's asking to find EC. So EC is 5 units. Okay, so that's number 2. Let's go to number 3. I'm going to write an equation here with letters from the figure to represent the segments before I actually plug in any numbers. All right, don't forget to do that on the final. So segment AB times segment BD equals segment CB times segment BE. So now I can plug in my values. AB is X, BD is 10, CB is 16, and BE is 15. So that's going to be 10x. 16 times 15, well, I know 15 squared is 225. So an additional 15 plus that 225 is going to be 240. So x equals 24. Okay, number 4. This is a quadratic equation. So I'm going to solve this by setting it equal to 0 so that I can factor. So move over the 5x with subtraction. That's going to give me x squared plus 2x minus 5 equals 10. And then I want to move the 10 over with subtraction. So I can set it equal to 0. So I get x squared plus 2x minus 15 equals 0. All right, so factoring time. I need factors of negative 15 that are going to add to positive 2. So I know 5 times 3 is 15. I can make the signs work so that they can multiply to give me a negative 15. Like that, 5 times negative 3 is negative 15, and 5 plus negative 3 is positive 2. So setting each of these equal to 0 will give me my two solutions. So x equals negative 5 or x equals positive 3. Okay, so that is it for number 4. Let's move on to number 5. All right, number 5 says to identify the center and the radius of the circle and then graph it. So remember from your formula sheet that this is x minus h squared plus y minus k squared equals the radius squared. You don't have to write that down on your final if this is the type of question you're given, but just a reminder of that's why we pull out the opposite number, right? So when I'm looking here in my parentheses, I see plus 5, but my center, I'm going to think opposite, so that's going to be a negative 5. Same thing with my y. I see minus 1, so when I pull that out, it's going to be the opposite of minus 1, which is positive 1. The radius is going to be the square root of this number 9, and the square root of 9 is 3. So graphing my circle, I'm going to go to negative 5, positive 1, and then I'm going to count up, down, left, and right 3 units 1, 2, 3, to get for my radius so that I can make my circle. And do your best to make your circle. I understand it's not the easiest thing to do. But ultimately, we're trying to give you points here, but if you end up something that's more like a diamond, then we will take off. All right, so there's my circle for number 5. So that is it for review day number 3. Just a reminder again, not sure when you're watching this, but if you're watching this before Wednesday, the 28th, we will have an afternoon of review time in the math hallway, the first floor of the TUS, if you want to stop by and ask any questions. See you then.